Okay, good afternoon. Sorry about the slight delay, and obviously me moving the camera around so I can get everything working. Let me just check and make sure audio is coming through. Let's have a look here. Okay, just double checking the audio doesn't seem to be coming through up here. Let me just check, hold on. Okay. Let's see what's going on here. Okay, is that coming through okay? I can't see my mixer working. Oh, sorry, I'm just trying to figure out what's going on with my audio. Hold on 1 second, sorry. Unless, of course, you can hear me, let me know, but I can't see any readings coming out on my stream. So I just want to make sure the audio is coming in. I'm just going to go into the settings. Hold on 1 second, so sorry. Let's see what's going on here. Microphone, why is my mic not coming up? All right, microphone. Sorry, I'm just making sure. I don't know if you can hear me right now, or what. Let's see what's going on. Okay, there we go. Yeah, so my mic's showing up. Sorry, it's just not showing up in my streaming software, so I can't actually tell it. My computer is saying it's working fine, so I'm hoping it's working. No one's telling me that it's not working, so I'm just going to go ahead. All right, so welcome to the Bendigo Tech School's live streaming session. So today's session is all going to be on block coding. So remember, this is kind of like our intro to sessions for the next week or two, all about quick introductions to software and hardware and those kind of things. So today is all about block coding. Now, I'm guessing a lot of you had a very busy day with all your students back at school. So what we're going to look at really quickly is how to use Scratch. Now, Scratch is a block coding program. So block coding is, I guess you could call it a technique, or you could call it I don't know what you'd call it, a technique. But basically what it's going to do is it is all about getting, complex things like coding, which, generally have a lot of complex lines and language, and really simplifying that into visual blocks. So it's a visual way to code it. And it is still coding, okay? Even though it is using these blocks, it's still coding because, as you know, coding is basically a set of instructions. Basically what we're looking at is like, if I do this, then I want this to happen. So it is just instructions. So as simple as block coding may be, it is still coding at the fundamental level. And you can also make it really quite complex if you want to as well. So again, I really like block coding because it's really visual and really easy to understand. For instance, Raf, who's 6, he can use block coding to control a Sphero around because he kind of knows what blocks do what by how they look and the colors that they are. So a really good introduction into coding. So instead of me talking about it, I'll just show you. Okay, it'll be a lot easier. So I'm going to switch across to this screen over here. All right, so what we're looking at over here is Scratch. So Scratch is an online coding interface. You can also download it as well. So if you don't have reliable internet at school, you can download an offline version, which works just as good actually, if not better, because it doesn't require the internet, except it won't have things like cloud saving and sharing and those kind of things unless you kind of upload those programs to the cloud version of it. So the online version allows a lot more sharing of your Scratch programs, whereas the offline version runs without the internet. So there's pros and cons, I guess, of both of them. So here is Scratch over here. Now you can join Scratch. It's free. It's by MIT. You can join it and sign in, like I said. If you do sign up, it'll give you an account. It'll give you a cloud account with online storage, so you can store all of your creations up there, and they're always going to be there. You can access them from anywhere, which is great. And you can also, like I said, you can share your programs, let other people remix them as well. So that's really handy. So, excuse me. So if you join Scratch, that's what you can do. But I'm just going to jump straight in without even signing up. So let's go into Create. Now, block coding isn't the sole, I guess, Scratch isn't the only block coding program out there. There's quite a lot of them now. I'd say they were one of the first, but now you've got things like Google have it, Microsoft do it. Pretty much anyone has got a block coding interface and program. So you can kind of use any of them, and they will fundamentally do the same things. Scratch probably being the first, and I think probably the best, is the one I would use because it also is plugged into a lot of equipment as well. So for instance, if you come into the tech school and use the Cody Rockies or the Spheros or any of our kind of robots like that, they're all using block code and they're using Scratch block code as well. So again, I would probably stick with it. I think it's also the cleanest interface too. So this is the interface that we're looking at here. We have all of our code down the side. We'll talk about that in a second. We have our costumes, which we'll talk about those in a second as well, and sounds in these 3 tabs here. But the main space is this kind of grid in here with little dots. That's where we're going to do all of our programming. Then here, this screen is actually showing us directly the output. So we're actually seeing our program run here in this space. So the good thing about coding, especially for young people, is it allows them to just kind of throw some stuff down here, hit start, and see what happens. So, you know, we talk about failing a lot at the tech school. You know, we really try to fail as fast as we can. So this is a really good way for students to see what they're doing and then seeing the outcome and going, well, what do I need to change? Let's go back and make some changes. Hit the enter key. Is it working? Is it not working? So really easy way to kind of test their programs out straight away. So that's that screen over there. And then down here we have, I guess, our sprites. Now, Scratch is a 2D program, okay? So it only works on X and Y axes in terms of its visuals. So we're only looking at 2-dimensional images for anything that we actually are going to visually see on the screen here, okay? So no, it's not 3D. There's no depth like that, just X and Y. Of course, there are 3D programming software, but we're not going to worry about that right now. We just want to get into the fundamentals of it. And that is that there. And then finally, this panel down here is our stages. Our stages are the backgrounds. So the background images here. So we can program, obviously, these elements that we're going to put on this part here, but we can also change and program the background elements, which are the stages. So think of those, again, kind of like a PowerPoint presentation, and you can kind of jump between slides. You jump between backdrops down there. All right, so that is pretty much the interface. Like I said, I'm going to go through it pretty quickly because I'd rather spend less time on running you through this and giving you time to actually have a play with it once I'm done. So I'm thinking this might be a shorter session today, just so you can actually sit there and have a go at coding. But again, just let me know if you want any help after you have a go. Shoot us an email and I'll help you out. So we talked about code. Now here are the code blocks over here. You'll see they're all color coded. So we have blue for motion, so anything that requires movement. If you're going to have your character move up, down, left, right, those kind of things, then that's going to be a blue block. Looks are our purple blocks, I want to say. So they're visual cues. So things like actual text on the screen, visually changing things getting bigger, things getting smaller, colors changing, those kind of things. That's a visual change. So that's all. That purple color. Another purple color is sound. So if it's going to make any sound, if it's going to explode, it's going to have sound effects, music. Do you want to change the volume? All of that is done in that color. Our events, I want to say that's yellow, light yellow. These are one of the most important blocks here. This kind of starts our whole program off. So an event is like the if button. So if I do this, then this is going to happen. So for instance, if I press the space key, then I want something else and something else and something else to happen. So it's a starting point of your program, okay? So you can also have when the flag is clicked. So basically when I hit the flag, I start running my program. So very important, those events. The event kicks off everything that's happening, okay? Control is also another important, I mean, they're all important, but control is also important here. I'd say that's orange. And that controls our code, okay? Because when we put our code together, we might also need to control those smaller elements of it. So control will actually do things like that. And I'll show you obviously soon when I actually do some programming here, but we have things like repeating the section of code that we've got for a certain amount of time, repeating it forever, waiting before we want something else to happen. These if then else statements are really important. So if something happens, do this, or else do something else, and those kind of things. So control, really important. Sensing, so there's a little bit of sensing involved in there. So it'll sense if it's touching a certain color or if it can hear a certain sound or those kind of things. Sensing is kind of more important when you're using hardware. So if I was using the Cody Rockies we've got at the tech school, they've got light sensors, they've got sound sensors, they've got motion detectors, and so it'll be able to use all of those elements. So because I'm just using the software version of this and I'm just programming a sprite, obviously I don't see those extra elements there. Operators, so these kind of combine things together. So we can drag and drop blocks within blocks, and I'll show you these soon. So what we're saying is, like, say for this one here, you know, if this and this equal this certain amount, then only do that thing. So for instance, we could say if it's 6 o'clock at night and it's dark, then I want you to turn the lights on, okay? So it allows you to combine certain elements to get an outcome as well. Things like if a number plus a number equals, then do that. So a lot of different changes there. Again, this will make sense once I show you a code in a second, so don't stress if it's kind of freaking you out with all of the things. Variables are quite complex. I probably won't really mess with variables now. And then we've got my blocks where you actually make a block. So we can make a block that does a certain set number of things. and then that becomes your own block, and you can call it, you know, Daniel's block. And it saves you having to do the same bits of code all the time. You wrote your own basically in a block, so that's what that is. But let's see this in action, okay? So it'll make more sense once I show you what's going on. So I'm going to take again, it's an intro. I'm going to make a video game really quickly. All right, and I'm going to use this little cat. We'll talk about adding your own sprites in a second, but I'm going to use the cat that's there and ready to go. All right, so first things first is I want it to move. So what we would do is go into our motion here and look at, obviously, all these options we have for movement. And we have this one here called move 10 steps. So I'm going to drag that and drop it and let it go. Okay. Now you can drag and drop anywhere in this space. It doesn't really matter. And they can also be dragged. You can have multiple bits of code all over the place. They don't all have to be sequential. All right. Now remember I said we need to have some kind of event happen. So some kind of if statement. So if I press a button, then I want you to move 10 steps. So if we think of this like a video game, if I press right on my controller, I'd expect my character to move right. So that's what we're going to do. We head into control. We head into events and we grab the when and we drag it off. And see how you get that kind of grey snappiness there? So that tells me it's going to snap to that. And I've got when space is pressed, but I'm going to change that to the right arrow. All right, and now it's ready to go. And you can see this little cat up here, how he's kind of a little bit opaque. That's saying that this is going to program this, okay? So this code is programming this, and we can see it up there. And we can change that. If we have different elements on the screen, different sprites, we can control those different sprites by clicking on them, and it'll change that image up there. So let's just try that. So I'm going to hit the right arrow. And there we go, my cat is moving, okay? You can see it flashes yellow because the program's running, and my cat moves 10 steps. Now, if I press the left key, I want him to go back. I'm going to hit the left key, and nothing happens, okay? Because we didn't tell it to do that. Now, that's a big one you've got to get into your students' minds as well, is code is very clever, but it only does exactly what we say. Now, you know, I'm sure if I told Raph to move to the right, and then I said, oh, now move to the left, he would do that, okay? But our program won't, our little cat won't, because we actually have to tell it. We have to code it to do that, to take that, that cue, which I guess makes sense. We don't want our programs doing whatever the heck they want. So let's do the same thing. So you can see I can drop it wherever I want now. I'm going to move that one over there. I'm going to change that to when left arrow is clicked. I'm going to go back to motion and I'm going to do that move 10 steps. So let's test this out. I'll just move my cat across here so you can see it. So I press my right key. You can see the right is flashing, so it's working. And now I'm going to press the left key and it's working, but you can see we have a problem and he's still going to the right. Okay, now that's what I mean by being able to have that instant feedback. So I can see straight away, I've got a problem, and now I need to figure out what that problem is. My code looks correct. If I hit right, he moves right. If I hit left, he moves right. So these are the problems your students will come up with, and hopefully they'll be able to problem solve and figure them out themselves. That's what we try and do. We try and get them to figure it out as opposed to telling them what to do, obviously. Because then what they learn from doing this one step, they will then incorporate into a lot of other steps we do. But I'm going to speed this forward. So we can see here we've got 10 and 10. So that's obviously the one thing that's still the same. These are different, left and right, but these are 10 and 10. So when we look at this, we've got a positive number here, and we also have a positive number there. And so coding is very much based upon maths. So with two positive numbers, this is going to be going to the right, where positive numbers go. So we need to actually make this a negative number. So now we're saying go backwards. Okay, whoops. Go backwards 10 steps. So 10 negative steps means it's going to go to the left. So let's try that out. And there we go. He's moonwalking to the left. So now we have a right key and we have a left key. Okay, so our little character is starting to work. Okay, now obviously he's going the wrong way. He's not spinning around. We'll get to that in a second. I'll show you how to do that. But for now, left and right moves your character pretty easily. Okay, how's chat? Everyone's good? Any questions, let me know. Obviously, it's probably about a 20-second delay on YouTube, so type your question in and I'll get to it. But let's keep on going. So, we had him go left and right, but now we'll make him jump. So again, we go into our events. We drag that in. I could say up key if I wanted to. I'll leave it at space. Space makes sense. We'll go back to motion. Now, I want him to move up, so we had a move here, but as we scroll down, we can see we really don't have an up and a down. So this is where, like I said, you want your students to start learning these kind of fundamentals because it's going to start to roll into other things they do. So hopefully when they figure this one out, they realize that maths is important, okay? And negative and positive are important. So hopefully they will jump to the conclusion that obviously X and Y are also important, and X and Y mean different things. So down here, I like this because it helps us to remember. So X is left and right, and Y is up and down. Okay, so what we can do here is I can then grab change Y by. So I'm going to put that over there. Now we could have also done change X by here too, and that still would have worked because it was X and Y. But I like to use the move because I think it's a bit easier. So change Y by 10. So if we try that out and we hit space, all right, that's working. I'm hitting the space and he's moving up by 10 points. Now, again, this is where learning kind of Scratch sequentially, step by step, is really helpful. So now your students have realized, all right, cool, he can go up, but if I want him to go down, because that's what a jump is, I must need that negative step in there. So we go back into our motion here and we'll go change Y by, and we'll drop a negative in. So we're learning every step of the way. Whenever we do something, we're learning. And you can also see now our code block is getting a little bit more complex. We now have 3 blocks stacked up here. So let's try that out. I'm going to hit space. All right, and so something's not working again. We need to figure that out. Now, if I didn't have a 20-second delay on YouTube, I would have asked someone to tell me what they think the problem is, but let's just kind of move on. So again, we look at this and we need to problem solve. We can see it's running. I said change 10 by Y, change Y by 10 and then change Y by minus 10. So that's also correct. So what could the problem be? All right, what it is, because I'll tell you, is that our code, like we said, our code does exactly what we say, okay? But it's also very, very fast. So what we're going to see here is in this sequential order here, it's going to run those two things, but it's going to do them basically at the same time. So it's going to move up and down and cancel itself out because it is so quick. So I talked about control before, and that's where we start to use these control blocks. So I'm going to drag one of those in between and let it go. I'm going to change that to 0.2. Okay, and then I'm going to hit the space. There we go. So now we have a jump. So hopefully what's happening, especially if you've never used Scratch before, is you're reading this and it's starting to make sense now without even having to see the output. So when space is pressed, move up by 10 points on the Y, wait for 0.2 of a second in the air, and then come down minus 10 steps on the Y. And there's our jump. All right. So now let's kind of make it a little bit more complex. Let's add a couple of layers to it. And you can see I can just keep adding layers into this. Okay, so code, when they talk about code, and they talk about lines of code. So this, for instance, is like 1, 2, 3, 4 lines of code really to make this simple jump animation and jump control. But if we were making a video game, video games are talking about millions and millions of lines of code. So it's constantly adding to that. So let's change a couple of things. I'm going to go into sounds. Let's do an easy one. I'm going to put this here, and I'm going to put that one under there. So now we have it making that meow sound as well. So we keep adding it in, all right? That's gotta be annoying. So now let's do some more, right? Let's keep adding onto our little cat here. So you'll notice when he jumps, visually he stays the same. He doesn't look like he's jumping. So let's change that, and we're gonna go into our costumes. So the sprites that are built into Scratch are a whole bunch of them. If I hit the plus button here, you'll see a whole bunch of these sprites that are in here already. Now, sprites are just, think of them like animated GIFs. They're just like different frames of animation, all right? Or they can be a single image, all right? So you can see we have these different kind of scenes. So I'm just gonna go back. And my cat has 2. It has costume 1 and a costume 2, okay? So what I'm gonna do, I'm gonna go back to my code, and I'm gonna go into looks because it's a visual change, and I'm gonna put this in here, and I'm gonna say I want you to jump in the air and switch to costume 2. So if I try that out, works. So he's changed into a different costume, right? So he looks like he's jumping, but our problem, of course, is now when he jumps down, he hasn't switched back. And that's because we didn't say that. We can see we're saying switch to costume 2, but we haven't told it to switch back to costume 1. And again, that's code being very, very specific, and also being, you have to say exactly what you want to happen or it won't happen. It's super literal. So what I'm going to do is I'm going to put that under the weight. I'm going to say switch back to costume 1. So now if we try that, we can see that jump. And if we want to make it more pronounced, let's change that to 20 points. And that one to minus 20. And then I'll run that. There's that jump. All right, so now we have a cat going to the right, a cat going to the left, still moonwalking. That's probably really annoying, I apologize. And a cat jumping, okay? So you can see how I'm just slowly starting to add on to this code to make it more complex. Now we can see all the code to make this happen. So let's take what we've got about our costumes here, and let's use it for this action here where we wanted to go left and right. So we go into our looks, and what we can do is we can do the same thing, okay? So I'm gonna make a new costume because we only had 2. So I'm gonna go to my costumes. I'm gonna go down here. I'm gonna duplicate that one. Actually, no, I don't want to duplicate that one, sorry. I'm just gonna duplicate costume 2. which is now, I'm going to move it down to there, costume 3. And I'm just going to grab this little fella and I'm going to flip him. All right, so now I've got a third costume in here. Okay, head back to my code. Excuse me. And what I'm going to say with the left arrow is I'm going to say switch to costume 3. So now if I press the left arrow, he goes that way. But of course, now if I go right, he's been walking the other way because we then have to make sure we remember, bring that one back in and switch that to costume 1. All right, so now we have a left, we have a right, and we have a jump. So it's pretty simple, but that's kind of how this works. So I'm not used to this keyboard. That's how this works. So now we have a moving little animation, okay, running through here. And that is basically it, right? So that's coding. So if we can read this, it's if I do something, so if I press a key or if I press start on my program, then I want you to do these things. And you can see how it works. So then in this case, I want you to play the sound. I also want you to switch costumes and I also want you to jump up 20 points. I want you to do all of that. Then I want you to wait. And then I want you to switch back to the costume 1 and then jump back down again. So it's very visual and it's very, very straightforward. So, really good kind of games that you can play with your students where they are not using a computer, okay, is you can get them to do, code each other just by writing things down on paper. Can they write a set of specific instructions that they can pass to their friend to then follow and do that exactly? Hey, bud.
Are you coding again?
Yeah, we're doing the coding with Scratch.
Cold.
Yeah, I know, it's cold in here. Can I get back to it? Okay. So again, you can do those simple little games with your students so they can understand this kind of concept that everything is sequential and everything requires, these very specific steps. So if I do this, then do that. Oh, sorry. If I do this, then do that. Okay. And that's kind of how you run through your entire program. So let's look at a couple more things and then I'll let you go. So I talked about these things down here. Okay. These if then else and these repeat. So what I'm going to do is I'm just going to shut the door again. Okay, so let me explain how these work. All right, so what we're going to do is you can leave this code up here if you want to. So I'm going to put this one over here and I'm going to use a sensing block. So you can see here, we've got these different shapes. All right, so if we have a look at a lot of these shapes, they will kind of help us out into what fits in what, basically. So what I'm going to do here, I'm going to find, what am I going to do actually? I'm going to say, let's have a look. I might do a sound one. Okay, so I'm going to get this one down here and I'm going to say, let's grab that. And I'm going to go into sensing and I'm going to go loudness. All right, and you'll see with a tick, you'll have to get something like this, like allow microphone. I'm going to say allow. Now, hopefully this works. It does. Okay, so now you can see this loudness is turned on. If I turn it off, it turns it off. I'm going to turn it on now. There we go. And we can see my microphone is on and it's sensing the volume in the room. And we can see it as a number. So if I be quiet. Okay, you go, buddy, and you'll be right, okay? Sorry about that. So you can see it's kind of picking up my fan speeds and stuff, but it's pretty big up and down. So when I talk, we make a change. So let's look at how this works. So I've got loudness. If loudness is greater than 50, I want something to happen. Okay, so I might make that 60, just to be sure. Okay. Then I'm going to grab that and I'm going to put it in here. So if the loudness is greater than 60, then I want you to do something. Okay, so let's go into here. We can do whatever we want. I might just say, let's put this sound in here. I'll change it to record. Loud, loud, loud. And we'll trim that. So you've got a built-in sound recorder.
Loud, loud, loud.
And I'll bring it out here and I'll save that. Okay, so now I've got a recording one. I can rename that to something else. So I'm going to go down here and I'm going to say recording one. Hold on one second. Sorry, everybody. Yeah? Okay, can you help yourself? I will be back in a minute. There is a toilet emergency. Okay, sorry about that. We are back. All right. So where were we? So we were talking about our loudness here. So I'm now saying if a loudness reaches a certain level, then I want to play this recording. All right. So we still need to start our program. So what I'm going to do is I'm going to go into our event and I'm going to put on when this is clicked. So when we start our program, this is going to happen. Okay. So I'll start the program and then I'll make noise and we can see that nothing's happening. All right. So let's see what's going on. So remember, okay, close the door. So remember, we need to kind of test our program out to see why it's working. All right. So let's see what. In a second, darling. So let's see what our problem is. Let's see why it's not working because we're hitting 60, obviously, and we're not hearing that loudness. Okay. So we said when this is clicked, then if the loudness is greater than 60, then play this recording sound. So let's have a look, and we'll try something simple. Let's go and change our operator around. All right. I'm sure lots of you are screaming about that. So, whoops, I'm going to get rid of that. I'll get rid of that. I'll put that one in there. I'll put that in there. And we'll try that again. Loud. Okay, so still nothing happening. So let's try and figure out what our problem is. Because we've got if is greater than work. But for some reason, obviously, it's not working. And I couldn't even tell you why. So let's just test our recording. Our recording seems to work. So we'll try that again. All right, so it's getting loud, but we're not hearing our recording. Now, I wonder if it's got anything to do with my microphone. Let's have a look. Let's go back into my control. What I might do is I'll just try that again. So it seems to run.
Loud,
cool.
loud, loud, loud.
I figured out my own problem. All right, so if we head back into our control, and I'm sure a lot of you were screaming just then. Remember I said we have these ways of running our code, okay? So if we go down here, I've got a repeat loop. So what was happening was when I was running that program, see how it's running for a second, really quickly? Because that's what our program says. It's basically saying when this is clicked, sense for the loudness and then play this volume. But it ran that straight away. It ran it instantly, okay? And so what happened was because I didn't hit that certain volume at that certain time, the code stopped. So that's where these repeats and forever loops come in. So I'm going to put that over there now. And now if I hit this, can you see, Ruff? Now if I hit this, what's going to happen is my program's going to run, but it's going to keep running. Okay, so it's going to keep looping this until this happens. So if I hit play.
Loud, 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 loud.
There we go. So you can see that was working because what was happening was it was repeating this block of code. And what was happening obviously too was because what my volume was playing, that sound clip was playing, it kept hearing that and it was going to just keep repeating itself. So what we can do here is go back into our control and we can kind of get it to kind of wait for a little while before it starts to do it again. So we can say play that and then wait for a few seconds. Let's say wait for 5 seconds before you try and sense it again. So let's do that. Hello, this is noise. 2, 3, 4, 5. And then we can kind of keep looping that through so it doesn't keep basically running forever and just kind of doing that same bit of code every time, which is cool. So let's just try that again. So that's what our kind of if then else's if statements do. So then we've got an if then else. So we'll go into that. And what we can do is we'll take this out and we'll put this in here. So you can take these blocks out individually.
Bye-bye.
See you, bud. All right. So now what we can do is we can say, right, if this is happening, I want you to do this. But if this is not happening, then do something else. Okay? So, yes, darling.
Where's the present, Mum?
We'll worry about it later, darling. Not a good time. Okay. Don't worry, darling. All right. So what we can do down here is we can say, if it isn't this loud, we can have something else happen. So what I might do is I might just put a look on here. All right. And I'm going to say, all quiet. All right. And then I'll put my forever loop in to make sure I remember to do that. And then I'm going to put this over here. We'll get rid of these. So now if we read our program, what's going to happen is it's going to run forever. So it's constantly going to be running this bit of code. If it hears something loud, it's going to play that recording. Okay. But if it doesn't hear anything loud, it's just going to display quiet. So let's try that. And then when I make noise,
Loud, loud, loud.
it starts to play that recording. Okay, so that's as simple as that. So if then else, okay? You'll notice all quiet stayed up and it stayed on the screen. So what we want to do is we want to change that code a little bit, all right? Because we don't want it to stay on when the alarm's going off saying it's too loud. So we'll change that to all quiet. I'll make it last for a second. All right, then we'll run that. Loud, loud.
Loud, loud, loud.
There we go. And then it starts running through there as well. Okay, so that's our if then else statement. So hopefully that kind of made a little bit more sense. And we also learned obviously that we need to also have, when we're sensing something, we need to have these kind of forever loops going on. So the code is constantly sensing that. So it's going to keep running. All right, so that's probably enough really in terms of how Scratch works as an introduction, because I really want you to kind of play around with this yourself. Down here, you can see we've got a bunch of different, these are called extensions. So I'll just go back. So I was talking about how this is all software based. So this is just controlling our sprite. I can add sprites. I'll add an apple. Okay, so there's my apple. So remember what I said too, if I click on the cat, then there is all the code for the cat. And if I click on the apple, or the other sprite, there's all the code for the sprite, which we haven't done anything. So you actually program each individual sprite separately. Okay, so I can code the cat to do things, I can code the apple to do things, and with the sensing, I can get them to actually interact as well, because we can say if there's a distance to a certain sprite. So I can say if this apple is close to this cat, then I want the cat to move forward and eat it. So we can do things like that. But that's your sprites. But down here are extensions. So this allows us to add certain elements to it. Okay, so we have a few things down here. We have the Makey Makey extension. I know some schools have Makey Makey, so this allows you to basically control a Makey Makey, a microbit. All right, so with the microbit, that's a hardware bit of machinery there. So you can plug a microbit in and you can code it with Scratch, which is cool. And also EV3. I know BSC, Paul, I know you've got lots of EV3s. So you can actually use Scratch to control your EV3s instead of using that kind of Scratch interface. That EV3 interface, which is a little bit scary. So you can use that as well. So these are your extensions. And also there are a bunch of other extensions that hardware uses. So like I said, our coding robots have extensions to work in this as well. So I'll head back. So that's our extensions. We talked about our sprites. We talked about how you code each sprite individually. Okay, so let me show that again. So if I have my cat here. So we did our cat moving code, right? So let's do a little bit of sensing while we've got this as well, so you can kind of see what's happening. So let's go into our sensing block, and you can see here I've got distance to apple. So what I'm going to do is I'm going to go in here, and I'm going to basically say, let's go into looks. All right, and I'm going to bring this over here. I'm going to go into my sensing, and I'm going to say I'm going to change that to apple. All right. Oops. And then I'm going to go here, and I'm going to say yum or yim, yum. And I'm going into my sound, and I'm going to say, let's do a new recording sound, and I'll just go, bite. I don't know, that's meant to be a bite of an apple, right? You can also upload sounds if you want to, you don't have to use these. Okay, let's do that. And I'm going to say, recording 2. You can see this gets pretty messy here at the moment, but that's okay. We can if you don't want to use these things, you can just delete them. You just chuck them over there, and I'll delete. All right, so if touching the apple, say yum, and play that sound. Remember, we need to put that forever on. So it's always scanning for this. It's always waiting for this to happen. And then I'll put that one on there. Okay, so let's try this out. I'm going to hit the start. We can see it's running because it's yellow. It's running this piece of code for us. All right, and it's constantly on a loop. So it's basically waiting. That's why it's a sensing block. It's waiting for this to happen. So let's move to our apple.
Nice.
Move away from the apple. He stops, move back to the apple.
Nice.
All right, so you can see there's a few issues there, right? And again, this is where our coding comes in. So first, it keeps saying yum. Notice how, I'm going to turn loudness off actually, because we don't need to see that anymore. Notice how yum is still on the screen, because our coding here didn't say to stop saying yum, okay? So once it's being said, it's always going to stay. So let's go back into our looks. Let's change our code, okay? So again, this is where really cool problem solving for students to figure this stuff out as they go. So we'll say yum for 2 seconds. Okay. Then you saw that it kept repeating that sound, that yum 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 kept playing, because we just said start the sound. We didn't say how long to play it for. So I'm going to go back here and I'm going to say start recording until done. So it's going to play it and then it's going to stop when it's finishing saying it. All right, let's try that. Let's run our program.
Ice. Ice.
There we go. So it's only playing that recording
Ice.
until it's finished.
Ice.
There we go. So
Ice.
amazing. So that's how the sprite's going to interact with each other. Okay. So you can get quite complex with this and play a game. You could actually code a game of, say, soccer, where you have a ball sprite, and then you can say if a character hits the ball, it moves across the screen, and then another character has to hit it and make it come back. So you can get really complex. But anyway, let me show you one last thing, and we'll do backdrops. So here are the backdrops. Here are the backgrounds to your program. So let's just use basketball. These are just images, okay? They're just kind of like JPEG images, so you can add your own if you want to. All right, go down here, blue sky. So you can add as many backdrops as you want, okay? You can paint over them, all right? Or you can upload your own backdrop, okay? And you can also change these stages too. So you can change the stage to be something else. So what you can do is you can have an animation where he walks off the screen and then the stage or the backdrop changes to something else. So you can do that as well by playing around with this. So you can see we've got this switch backdrop. So what we could do in our program is we could decide to, at a certain point in time, switch the backdrops, or we could say if the character walks off screen, switch to, you know, a different backdrop in our scene. Okay, so that's easy to do as well. All right, so that's enough from me. Sorry about the couple of interruptions that we had. Raph's back at school now, so whenever I pick him up, he's home and he wants to eat the whole time. So let me know how you go. Have a play with that. Have a bit of an intro and see how you go. Now, if you were logged in, like I said, you can share these programs. And what happens when you share is it creates a copy of your program and a link to your program online. And if you share that with somebody else, okay, if you share that unique link with somebody else, they can grab your program and make a whole bunch of changes to it, but they don't change your original program, which is cool. They can add to it, they can remix it, they can recode it, and what will happen is it'll make like an instance or a copy of that that's now theirs, okay? But it keeps that trail, so it knows who originally had it, who originally made it, and you have this really cool branching path of all these different programs. So that's something to try as well if you're logged in. But that'll do it for me. So have a play when you can, and let me know how you go with all your Scratch projects. Like I said, knowing Scratch will be really handy coming into the tech school, especially for students, because it'll allow them to do things like control all our robots. So if they already have an understanding of Scratch, they'll be able to jump in and control those robots and, you know, save a whole bunch of time and not worry about having to move cats because they're busy moving like little robots on the ground. So that'd be great. So that's it from me. I'm going to end the stream today, and I will see you all next time. Now tomorrow, what do we have tomorrow? I should check. Tomorrow we have, oh yeah, video. Okay, cool. Video editing. So we've done video editing with Premiere Pro, but tomorrow we're going to be looking at video editing with Final Cut on the Mac. So if you're a Mac user and you're using video editing, that is all for you for tomorrow. So make sure you register. And then on June 11, we have another one of Matt's Autodesk Inventor Masterclasses. So that'll be very, very cool to watch in. Like last time, there will be videos that are pre-recorded, so you'll have plenty of time to watch those. We'll put the premiere date up soon when they're ready to go. So thank you very much. I'm going to end the stream, and